Hello there, this is Daniel, and the topic for today is momentum and impulse. Let's start. Momentum is the product of an object's mass and its velocity. It is a measure of how much motion an object has. The formula is P equal m times v, where P is momentum, m is mass, and v is velocity. An object with more mass or more velocity has more momentum and is harder to stop or change its direction. Their units are kilograms meter per second, kilograms, and meter per second, respectively. Impulse is the change in momentum of an object caused by a force acting over a specific time interval. Its formula is J equal F times delta T, where J is impulse, F is the average net force, and delta T is the time interval over which the force acts. Impulse is the kick or push that causes an object's momentum to change. For example, a longer time to catch a ball results in a smaller force because the impulse is spread out over a longer duration. Their units are Newton second, newtons, and seconds respectively. When a net force acts on an object for a period of time, it results in an impulse, which causes the object's velocity and therefore its momentum to change. Here I will show you some real-life applications for momentum and impulse. The first example we can see is in sports. Athletes and coaches use impulse to improve performance. A powerful swing in tennis or golf, for example, maximizes the impulse to increase the ball's velocity and momentum. In contact sports like football, athletes learn to absorb impact by extending the time of contact, which reduces the force of the collision on their bodies. Understanding impulse helps athletes time their movements, such as baseball player timing their swing to hit a pitched ball. Another example is on space and engineering. Rockets work based on the conservation of momentum. They expel hot gas downward at high velocity, and to conserve momentum, the rocket is propelled upward. Gyroscopes use the conservation of angular momentum to keep spacecraft and satellites stable and in the correct orientation. On the space station, momentum is used to measure an astronaut's mass because gravity is not present, rendering traditional scale useless. Engineers use these principles to design impact-resistant structures like bridges and buildings that can be withstand forces from collisions or other events. And to finalize with this topic, we will do an exercise. A 1,300 kilogram race car is traveling at 80 meters per second, while a 15,000 kilogram truck is traveling to 20 miles per second. Which has the greater impact? Now, the procedure is with first momentum, we are gonna multiply the first mass with the first velocity, which is this and this, which gives us a result of 100,000. Now the momentum 2 is 15,000 times 20 miles per second, which gives us a result of 300,000, which is the greater